In this video, I wanted to go over example number 3 from our notes. We are using Snell's law to figure out the index of refraction of this prism. So the problem gives us this picture on the left here. It says that there's a prism. We're given the angle of 30 degrees here, 60 degrees here, and it's a right angle here, 90 degrees. And we are given that the light is coming in this way to the right, and then it's refracting into the air in this direction here, and we are given this angle of 22 degrees. And we want to know the index of refraction of the prism, which we can see in this diagram. We're going to call it N1 because the light is incident from this first material. We don't care about the light coming in here because it's coming in straight, so it's not bending. So we already know the direction here that is horizontal, so we don't care about over here on the left side. So the medium from which we are incident is the glass, right? N1 is what we're looking for, is for the glass prism. And 2 is where the light is going to go into the second material. So as we see here, N2 is equal to 1, because air has an index of refraction of 1. And we are given this angle 22.6 degrees here that this ray makes with this horizontal line. For Snell's law, which I will write here, N1 sine of theta 1 equals N2 sine of theta 2. For Snell's law, we need the angles defined with respect to the normal to each surface. So this picture does a good job showing us everything that we need. I know it's a lot to take in, but let's just look at one thing at a time. If we look here on the left side, we have this dashed line here, which is a normal to the surface. That means that it makes a 90-degree angle with this diagonal surface here, the slanted surface. So once you have drawn your normal with the dashed line, then we need the angle that this ray is making with this dashed line here. So that's angle 1. That's called the angle of incidence. The reason that we know that it's 30 degrees is because we know that in the triangle we are given 60 degrees here. So that means that this must be 60 degrees as well. And that is because we have two parallel lines and we have the slanted surface here, so these two angles are the same. So once we know that this is 60 degrees, then if we have drawn our normal to the surface, which we know is 90 degrees, then we know that we must have 180 degrees for a straight line. So we have 60 and 90, we must have 30 here. Right? This is also a right angle on this side, so those two must add up to 90. So that's how we know that theta 1 is equal to 30 degrees. So it's not explicitly given, but we have to figure it out based on the angles that we are given. And then we also need to figure out theta 2, the angle of refraction. So that is not the 22.6 that we are given, because we need the angle with respect to the normal. So once again, this picture has shown us the normal to the surface, this dashed line over here. The outgoing ray is in this direction. So we need this angle right here. That is the angle that the outgoing ray makes with that normal. That is angle 2, the angle of refraction. That's what we need. And if we can see, the angle 22.6 that we're given is called phi in this picture. That's just this angle right here. But in order to get the angle of refraction, the full angle of refraction, it needs both of these little angles that add up to theta 2. So we need to know this angle over here, which has been called theta 1 because it happens to be the exact same angle as this angle right here. These two angles are the same. And the reason that we know that is because we have the normal line here, and we have the horizontal line here, this horizontal line, straight line. So these ones that are called theta 1 are really these opposite angles right here, so those are the same as well. So once we know theta 1, which was 30, and then we know the 22.6, then when we add both of those angles up, we're going to get 52.6 degrees. So hopefully this picture helps to show that. And now we can use Snell's law to figure out what is n1. We know that n2 is 1, so that cancels out. And then n1 is going to be equal to sine of theta 2, which is sine of 52.6 degrees, divided by sine of theta 1, which is 30 degrees. Make sure you are in degree mode in your calculator, and that will give us our final answer, which was in the notes, and I'm pretty sure it was 1.59. So hopefully that helps, and we will do other examples that require us to figure out these different angles. That's the trick for these problems, is to make sure that you are using the correct angle. Don't just automatically use angles that you are given in the problem.